In this video, we will look at the domain, which is the set of all possible input values, given the equation for a function. Looking at our first equation, we have y equals x plus 1. This is in the form y equals mx plus b. Therefore, our function must be linear. Based on knowledge of the graph, we know that the domain is all real numbers. However, let's take a look at the equation. Evaluating for when x equals 2, I will substitute 2 in for x plus 1. This will give me an output value of 3. If I substitute for x negative 5, my output value is y equals negative 4. Therefore, there are no restrictions, and my domain is still all real numbers. In the second example, we have the equation of y equals 1 over x minus 3. We know that we cannot have 0 in the denominator. The reason for this is for that is where the function is undefined. To calculate where the function is undefined, we can set the denominator x minus 3 equal to 0. If the denominator is equal to 0, this is where the function is undefined. We will solve for x and get x equals 3. Therefore, our domain is all real numbers, x not equal to 3. In our final example, we see y equals the square root of x minus 5. We cannot take the square root of a negative number. This will not result in a real solution. To solve for this, we want to set what is underneath the radical, x minus 5, to be greater than 0. Isolating x, we have x must be greater than 5. To check our answer, we ask, can x equal 0? Or can underneath the radical be 0? And the answer is yes. Therefore, x must be greater than or equal to 5. Checking our answers, 5 minus 5 equals 0. And the square root of 0 equals 0. So this works. Our domain is x greater than or equal to 5.